Welcome to Study Loop.
Okay, so these are the graphs I drew for the charge A, which is ER versus R and ER squared versus R. So if you take a look at the ER versus R graph for A, you realize that ER value is mostly constant as R increase, which means that A is an uniform line of a charge. And these are the two graphs I drew for B. And if you take a look at the ER squared over R graph for the B, you realize that ER squared is approximately constant as R increase. So therefore, B is an uniform charge sphere. And for question B, well, first let's determine the linear charge density for the A. So we know EA is equal to lambda A over 2 pi epsilon 0 RA. EA is the electric field. RA here is the distance, and lambda A is the linear charge density. So if we do some arrangement here, we have lambda A is equal to 2 pi epsilon naught 0 times ERA. So if you take a look at the table for A, if you do some calculation, you realize that the average value for A in ER value is about 2690 Newton meter per coulomb. And we know epsilon 0 is equal to 8.85 times 10 to the power negative 12 coulomb squared per Newton times meter squared. So if we plug in Basel equation, we eventually have lambda A is equal to 1.5 times 10 to the power of negative 7 coulomb per meter. And let's take a look at the B, which is the uniform charge sphere. So we know E is equal to KQ over R squared. So therefore, ER squared is equal to KQ. So Q is equal to ER squared over K. So we know rho here is the charge per unit volume, okay, which is the one we're looking for to determine, is equal to Q over volume. And we know volume for the sphere is 4 over 3 times pi R cubed. And R, capital R here is the radius of the sphere. So if we do some arrangement here, eventually we'll have 3 ER squared over 4 pi K R cubed. And we know the average value for ER squared in B is about 54.1 Newton times meter squared per coulomb. And K is a Coulomb constant, which is 9 times 10 to the power 9 Newton times meter squared per Coulomb squared. And we know the radius is given as 8.0 millimeter, which is 8 times 10 to the power negative 3 meter. So let's determine the charge per unit volume for B, which is equal to 3 times 54.1 Newton meter squared per Coulomb. And then over 4 pi times 9 times 10 to the power of 9 Newton times meter squared per Coulomb squared, and times R cubed, which is 8 times 10 to the power of negative 3 meter, and then to the power of 3. And this will give us the charge per unit volume for B is about 2.8 times 10 to the power of negative 3 coulomb per meter cube. And these are